Yeah, once again, welcome to the other part of the second session. We're going to be talking about data summary analysis on SPSS. Um, this is a type of analysis where you try to have a very insight of what your data is really about. And this analysis includes frequency, percentage, central tendency, which are the mean, median, and mode, as well as construction of some simple charts. Then finally, we will also look at cross-tabulation analysis. We will start with the frequency without wasting much of our time. We'll start with the frequency, and on SPSS, we are going to be using the data we got from yesterday's pretest that is available on SPSS. And don't forget that we exported our we imported our file, our data all the way from Excel into SPSS yesterday. So you can check previous videos for how to do that. Now let's go straight into frequency on SPSS. So I'll be sharing the data for yesterday. These are data for yesterday. The age, location, gender, course of study, total score, percentage, grade. Now, this gender was for that of yesterday, where we were modifying and we were also solving issues that has to do with missing data. So, after the missing data we corrected yesterday, it gives us a brand new data on the column. This the missing data were solved based on what we concluded on. So we should return to the previous video to check how to treat missing data. Now, I'm going to be running frequency of some data of this, or some variable on this data. Let's see. So I'm going to be running frequency of some variables here. For example, I run. So how to run frequency is very easy. All you just need to do is go to analyze. So descriptive, then frequency. So easy. So easy. So it now depends on the frequency you want to run. If you want to run the frequency of location, and I'm going to be running it and interpreting it. They want to run the frequency of gender, frequency of course of study in this data, and as well as the frequency of, let me see, we can run the frequency of age as well as percentage of percentage score. So let's see. Now we can click on statistics to run some statistics on it. How we are going to be running the mean, that is the central tendency. We run the median and mode, and I want to be running the minimum value and maximum. So this are what we are going to be running today. Let's continue. If possible, if you want to run some charts, run some bar charts, pie chart, histogram, whichever one. So let's run some bar charts. We'll come back for the rest. So I will also be clicking on percentage because I want the chart to be in percent. And if we also want it to be in frequency, we can click it. Whichever one, still a go. So click on continue and click OK. And it generates it in no time. Now, this is the statistics frequency. We notice that there are 0 missing values and we have 9 valid, which is correct. We also have frequency for location. If you look at it critically, you see that we have just one. Oshobo is the only one with where we have 2 participants from Oshobo, just 2. And the rest is one, and this is the percent. This is the percent. Then we also have that of gender as well. We have 4 male and 5 female, making 44 and 55% respectively. This is how to run summary analysis. Likewise for the course of study, you could see. Then that of age too. We have two individuals who are 24 years old and the rest just one. Just one. Now for the bar charts that we try to construct, and you can see we have only one, and we have around more than 20% that are from Oshobo. So likewise, gender, we have more male than female in this. And we have more medical laboratory scientists. Yes, now there's a problem. There's a problem. You can see because we run a string and it is saying, I think this is a very good point of learning. This is a point of reference for learning. You can see that it has two medical laboratory science. We have one with a capital letter and the other one with a small letter. So that needs to be corrected. That needs to be corrected. So how do we do that correction? How do we do correction? So what we just need to do is go back to our data. We just need to go back to our data. This is our data. Okay. Now on our data, we need to make the correction. Now this correction will have been made in Excel even before coming down. And because we have labeled our sample, our variable yesterday to be string, if you look at it, course of study is in string. So it will accept whatever you put there. Now it is accepting it regardless of the case. But because I did it manually, so most likely this kind of error is bound to happen. So I'm making the adjustments by just copying this to this place. So the adjustment will be made. So I'll go again, I'll analyze descriptive frequency, and everything is all there just like before. I'll just click on OK. So this time around, if you see that medical lab science is just one. It has recognized the one with the proper, if you remember from our previous class, with the proper function adjustments on Excel. So you can see it. So, and everything is all good. It's all good. So let's make some pie charts. So you go to the same thing, analyze, descriptive, frequency. Everything is all there, but we want some charts. So this is going to be pie charts. I'll click on OK. So to give us pie chart instead of bar chart. And this is bar chart. This is how it looks like. It gives it in percent. You can see. You can see, but we have more of medical laboratory science in this webinar for the group 1.1, and equal number of pharmacy, medicine, and public health respectively. So medical laboratory science is making total of around 66% of the total population in this webinar. So this is what a summary looks like. This is what a summary looks like. Summary analysis look like. Now we're going to be talking about cross tabulation. For cross tabulation, it's very easy. Cross tabulation simply means looking at the, the cross distribution of data of two categorical data. Don't forget the meaning of categorical data. It simply means data that cannot be measured um, by decimal number. It's not a continuous variable. It is a categorical variable, a variable that is being categorized, can only be counted and cannot be um, that does not have a decimal number. Example is the gender in this in this case. So if we check, maybe we want to let me go back to our data view. Maybe we want to check the cross tabulation of um, location and gender. The location and gender. We want to look at the cross distribution of location and gender. It's very easy. All you need to go is analyze, descriptive, and you see cross tab. I click on cross tab. If you want the location to be on the row, you click it, and you want gender to be on the column, you click it. Then you come back to now the observed count is going to be listed. The observed count will be listed. That's the amount of the values of male in every location, the amount of female in every location. So it's just the observed count. And if you want it in percent of the total number, you click it. If you want it percent in the column, the percent of the total of the column, you click it, the percent of the total of the row. But I will just click the percent of the total in the of the whole sample. So I'll click continue and we click continue. That's okay. Now 19, age 19, we have just one male that is age 19. We have zero female. For 20, we have just one. For 24, we have two of them, but we have one male and one female. We have 29. Don't have any female that is 29 years old. But we have down to till um, the highest number here, which is the highest age here, which is the oldest, which is a male. The oldest is a male, and the total amount of male is 5, as we've seen in our frequency, the summary analysis, and as well as the female as well. So this is the total. The total is 9, and 5 is 55% of 9, 55.6% of 9. So basically, this is how to run cross tabulation. So you can practice it and run it on others. For example, I'll run it on, I'll run gender this time around, cross tab, and I'll run it on instead of age, I'll run location. Yes, as I as I've used to make an example. So can see the location, Calabar, just one female from Calabar. We don't have a male from Calabar. Cross River, we have just one. We have everything we virtually one except Oshobo. We have one male and one female. So this is how to run cross tabulation analysis. And don't forget that in cross tabulation analysis, we use two dichotomous or two categorical variables that are not countable, not variable that are you can use variables that are continuous variables, such as age, or the score, or the percent with decimal numbers, but it's really good if you can use segmented or categorized, two categorized variables, where one will be in the column and the other one will be in the row. So this is how to run cross-tabulation analysis, and I hope it helps via practice. Now, our next and last topic we are going to be discussing for today is going to be data normality analysis. Data normality analysis. Now, what is the meaning of normality? Normality simply means a situation where a group of data is is evenly distributed, is normally distributed. Let me put it in that way, not evenly, is normally distributed. And when do we say data is normally distributed? Normally, data is normally distributed when it has three things. One, when 68% of the data lies between one standard deviation of the mean, 95% of the data also lies in two standard deviation of the mean. Within the two standard deviation of the mean, likewise, if it's going to be three standard deviation, it's going to be 99.7%. So that is how we, to know that, okay, we have a normalized data. If we don't have a normalized data, you will notice that there's going to be an outlier, like we've explained in our previous class. So I want you to, in case you want to revise, you can just check the previous video. A normalized video, in a normalized, excuse me, a normalized data will not have outliers. However, even though it's going to have outliers, it won't be much. But when you notice outliers, a whole lot of outliers, that you may not achieve a normalized data. And this is the graph representing a normalized or Gaussian. They call it a Gaussian distribution curve, where you have this characteristic parabolic shape, and you can see that you said that it is 68.2% from the mean, 95% or 99%. So whichever one you have. That's in and 1 SD, 2 SD, and 3 SD respectively. So this is how we get to know that we have a normalized Gaussian curve. So now, how do we now perform the tests to detect whether our data is normalized or not? And we're going to be doing that right now. There are three types of tests to know if you have a data that is abnormally distributed or very well distributed. That's we have three types of tests. It's either we use the first one, which is the skewness and kurtosis Z value. I repeat, is the skewness and kurtosis Z value, which should be between Z value should be between minus 1.96 to plus 1.96. Second one is the Shapiro-Wilk test p-value. Second one is the Shapiro-Wilk test, as I've mentioned, and that has to do with the p-value, which should be above or equal to 0.05. That's where we can see that, okay, it's normally distributed. And the third one is that we can use histogram, normal QQ plots, box plots on SPSS to ascertain the normality of a group of data. And there is need for us to determine normality of a group of data so that we can know what type of test to use. What type of test